Welcome to your lesson on explicit and recursive sequences. Sequences are a very big idea in mathematics. They appear in all aspects of math, geometry, algebra, calculus, and beyond. Let's take some notes. All the examples and problems we have in this presentation are to be written in your notebook. Please pause when you need to as you take notes. Let's begin with an introduction to sequences. Defined, a sequence is an ordered list of numbers. The order here is important, and each number in the list is called a term. Here are some examples of some sequences. Notice all of them do have an order to them, and each of these has, it looks like, 5 terms in it. 2 questions. Number 1, what is the third term in the sequence in letter E? Okay, if you look at letter E, in this sequence here, we have 1, 2, 3, 4, 5 terms. The third term is this one, so the value of the third term is 24. Next question, what is the value of term 8 in the sequence in letter C? Looking at that sequence, again, we have 5 terms, and the pattern is clear. We are adding 3 every time. So if this is term number 5, term number 6 will be 22, term number 7 will be 25, and term number 8 will be 28. All right, sequence notation. There's a way we usually denote the terms in a sequence that you should be familiar with. Here's a simple sequence. First term, second term, third term, fourth term. This ... means that the sequence will go forever, or it is an infinite sequence. And the way we label the terms, we can call them terms, elements, members. These all mean the same thing. More specifically, each term, most often you will see the terms expressed in this way. U sub 1, that means the first term. U sub 2, the second term. U sub 3, the third term. U sub 4, the fourth term, and on and on. So let's say we went all the way to what we call the nth term, some unknown term. We don't know if that's term number 10 or term number 110. It is just the nth term, some term in the future. So that one will be U sub n, and you can replace n with any number. So if we put 50 for n, that would mean the 50th term. Today we're going to look at 2 specific types of sequences. One is called an explicit sequence, and the definition of that is it is a sequence defined by a formula which uses the term's position n to calculate its value. Let's take a look. Here's an example. Here is an explicit sequence. N again represents the position. So the position appears in the formula here, and that's how we get each term in the sequence. So this one here is defined for n values greater than or equal to 1. In other words, you cannot put n values below 1 in here. You can't have n equals 0 or n be a negative number. Another thing about sequences is the n values, or the position numbers, are always integers, because you cannot say position 1.5 or position 2.8. You just say position 1, position 2, and so on. So n values will be only whole numbers or integers, positive. So let's take a look. First question. Write the first 3 terms in this sequence. So we want to know what term number 1, 2, and 3 are. All right, if we want term 1, we say position 1, and that means we make n into 1. So if we replace n with a 1 here, then that n is replaced with a 1 also. So here we're saying term number 1, or at position 1, you put 1 in here, and you're going to get the value of the term. So 2 times 1 minus 1 is 1. So the first term in this sequence is 1. Then you go U2. So now you replace this with 2 and this with 2. So U2 at position 2, or term number 2, 2 times 2 is 4 minus 1 is 3. So U2 is 3. And the third one, third term, again, we make this 3. We replace this n with 3 as well. 2 times 3 is 6 minus 1, 5. So we're basically, in this way, we can create this entire sequence. And the sequence is 1 so far, 3, 5, comma, ... goes on forever, because n can be any number greater than or equal to 1. All right, that's called a explicit sequence because the term number, or the position number, is right in the formula for calculating the term. So try this one. Let's try AI first. Looking at this explicit formula, give the first, second, and 10th terms of this sequence. Let's take a look. Term 1, U1. All right, so the n is replaced with the 1 as well. So here's 1. 3 times 1 squared is 3 times 1, which is 3 minus 2 is 1. All right, the second term, u2. Now we put a 2 in for n here and here. u2, here we go. 2 squared is 4 times 3. 12 minus 2 is 10. And now we're going to look for the 10th term, u10. All right, so we put 10 in here, 10 in here. So 10 goes in here. 10 squared is 100 times 3. 300 minus 2, 298. All right, let's try the next question, A2. Try that one out. Okay, to do that one, it says the term of the sequence with value 673. So now it's telling you what the value of the term is. So you replace the un, this part of the formula, with what you know, because you know that this formula will produce some term, and it's going to be, in this case, it produces 673. So you're saying, when will this formula produce 673? So you rewrite this 673 equals the formula, and then you solve backwards. So now we're going to add 2 to both sides. You get 675. Now we're going to divide by 3 on both sides, 225. Now we take the square root of that to get rid of this square, just like our quadratics unit, and we get n equals plus or minus 15. In this case, we eliminate the negative 15 and we say just n equals positive 15, because here again, n values can only be greater than or equal to 1. So at position 15, we have the term 673. To check that, you can always put 15 back in this kind of setup, right? You put U15 and you put 15 in here, and then you'll notice you'll get 673. All right, try the last question, part B. In part B, it says determine whether or not 524 is a term. This is just like this question up here. We're told what the value of the term is, and we have to figure out where in the sequence it is, what position. So I'm going to put 524 there. We're going to set it equal to the rule and see what happens. Add 2 on both sides, 526. Divide by 3, you get a decimal number, 175.33. If you take the square root of that, you'll also have a decimal number. So it's like saying to get 524, we have to go to position number, and it's going to be some decimal. Well, again, positions can only be whole numbers, so these values of n can only be positive integers. So this does not work. It means that 524 is not one of the terms in this sequence. Right, the second main type of sequence you need to know today is called a recursive sequence. This is different than explicit. The definition here is a recursive formula gives the relationship between consecutive terms. When you know one term, you can work out the next. Let's take a look at how that's different. So here's a sample. Look at how this is worded differently or expressed differently. So here we have u sub n plus 1 equals u sub n plus 2. Notice before the formula had un here, and then here it just had n. So if we plugged in a value of n or a position, we could get the value. But here, to get the value of some term, we need to know the value of another term right here. That's how recursive works. So here's how we can work with these. And there's more given in this one. In this problem, we're also given that u1 or u sub 1, the first term, is 1. And again, the rule is only true for n values greater than or equal to 1. So find the second and third terms. We know the first term is this. How can we find the second and third? Let's try this way. We're going to let n equal 1. So imagine this n becoming 1. If you put a 1 in here, this would be u sub 2. So if you make n 1, you're going to actually be looking for the second term, u2. So that became u2, because 1 plus 1 is 2 there. And on this side, we have, if we replace that n with 1, we have u1. So by making n1, we're actually creating a formula to find u2 using u1. And we know u1 is 1 because it's given here, so we're going to replace this u1 with a 1. So u2 is 1 plus 2, and that means u2 is 3. Next, to find the next term then, let's make n the next value. Let's make n equal to 2 now. All right, let's put 2 in there. So if 2 goes in here, we'll have a 3. So 2 went in here, became a 3. 2 went in here, and we have a u sub 2. So now to get the third term, we need the second term, plus 2. So again, every time you need a term, you need to know another term to find it. So to find u3, oh, this should say u3. To find u3, you put u2, which we just found here, in here, plus 2, and you get 5. So this sequence, again, is going to be 1, 3, 5. It's the same as the last sequence, but shown in a very different way. So last thing, try this one. Let's see how you do. Your goal is to take this rule and to find the second and third terms of this sequence. Let's take a look. The second and third terms, again, begin with n equals 1. u2 is applied to this rule, so when n is 1, this becomes 2, this becomes 1. So to find u2, we need u1. You put u1, which is given to you right here, into the rule, put it in here. So half times 12 plus 8. Half of 12 is 6 plus 8, 14. Now let's rewrite the rule to find the next term. N equals 2. So we have u3 now because this became 2, and that makes 3 there. And then we have u2 here. So to find u3, we need u2. Substitute the value of u2 we found here, and we have half of 14 plus 8. 7 plus 8 is 5, or sorry, 15. All right, there we have that sequence. Now that you've done that, please go on to the assignment. You'll find it on the website, link to the textbook assignment. There'll be 2 practice assignments from the textbook you have to complete, and you will practice both these types of sequences. Good luck to you. See you soon.